In this video, we're going to talk about arguments with quantifier statements for any there exists. So first type of question, use universal instantiation or universal modus ponens to fill in valid conclusions for the arguments. Now, so first of all, what is universal instantiation? So this, it means if some property is true of everything in the domain, then it is true of any particular thing in the domain. So let's look at an example to try to understand what this means. So for example, if we know all men are model, and so which means all means every single one, so that's like everything. So if this property is true for everything, then it is true for any particular thing. So for example, a particular person, a particular man, Socrates is a man, because by this universal statement, every single man is a model. Socrates is a man. Therefore, we can get the conclusion Socrates is model because he's a particular man. Okay, similarly, for a lot of math, a lot of formulas we learn in algebra class or any other class, physics class or any other class, that can be the when we apply the formula, it's like a special case of the universal instantiation, or we call it universal modus ponens if we use it as an argument. So here, let's look at a very simple formula we learned in algebra. X to the mth times x to the nth is equal to x to the m plus nth power. Well, we know this is the product of exponents equals the sum of the exponents. So if we know this formula works for any real number x and any integer, actually any real number m. So that if I pick, suppose x, let's pick, let's say we can pick 1.5, and an m, let's make it easy, let's pick whole number, say 1, and an n, let's make it a 2. Well, therefore we can get the conclusion. We can plug in here. X will be 1.5 to the first power times 1.5 to the second power. So replace x with 1.5, replace m with 1, and n with 2. It should satisfy, we should get the right side of this formula. So we keep the base 1.5, we add the exponents 1 and 2, so we should get 1.5 to the third power, and we can work this out to get an answer. Well, so this is using universal modus ponens, because this works for, the first formula works for any real number x, m, and n. So therefore, if I pick some special particular values for x, m, n, we should have this conclusion. After we plug in all those numbers into the formula, we should have the conclusion.